So let's solve another question with core and metallostatic forces that are involved in core. So the question goes as, find weights that needs to be kept to compensate for the forces during a sand casting of a cast iron pipe of 12.5 cm OD and 10 cm ID with a length of 180 cm. So the dimensions of the pipe is given. Next, the metal head, sorry, it's not head, it's head, is to be about 20 cm, while the molding flask dimensions are as 200 into 25 into 20 cm cube in size. Next, the density of the core sand is 0.0165 Newton per centimeter cube. Okay, the density of the sand and also the density of the core sand, both is given to be 0.0165 Newton per centimeter cube, and the liquid metal density is 0.0771 Newton per centimeter cube. So they have given the weight density. So the question is asking us to find the extra weight that needs to be kept on top of the cope of the flask. Okay. So first of all, we need to understand why extra weight needs to be kept. For that, let's understand what are the forces that are acting. So if we take only the core part, as we all know, the core is used to create hollow cavities inside sections in sand molding. Okay. So core. So what are the forces that are acting on the core? Obviously, the first one is weight of the core that is acting downwards, and next, since the core is present inside a molten metal pool, so we can think of it as some object that is immersed in a fluid. What force will be acting? Buoyant force will be acting. So the buoyant force is acting upwards, that is equal to the weight of the liquid displaced. So that is equal to density of molten metal into volume into gravity. Okay. So we can find the net upward force that is acting on the core by subtracting both of them. So this is basic max. You can do it, I guess. 5/4 into 10 square into 180 into 9.81 into the density. So yeah. So on doing this, we'll be having net force on the core as 856.712 Newton, and this force is acting in the upward direction. Okay, this is the first force that is acting in the upward direction. The next force that is acting is the metallostatic force. The metallostatic force is acting on the sand, the molding sand, using the core print. I guess you guys know what is core print. Core print is the extra, that protruding part of the core that is inside the sand. Okay, that is core print. So with the help of the core print, it is acting in the upward direction. So that force is equal to, as you all know, it is density of the molten metal into G into H, rho G H, into the projected area. So on calculating it, we find the value of metallostatic force as 3469.5 Newton in the upward direction. So the net force that is acting in the upward direction is both. We add both the forces. So basically it is 3469.5 plus 856.712 Newton. That is 4326.212 Newton. That is acting in the upward direction. Next, we will calculate the weight of the cope, the sand that is inside the cope. So they are given the dimensions of the molding flask. So on calculating it, we will be having volume, which is 200 into 25 into 20, into rho g, which is the weight density, which is 0.0165. So on multiplying them, we will be having weight of the cope, which is coming out to be roughly 1650 Newton. It is acting in the downward direction. So if we now see the system, we are having a net upward force of 4326.212 Newton, and weight that is acting downwards is 1650 Newton. So we can see obviously there is an imbalance of forces. So without an extra weight that is kept, there will be net upward force acting on the cope, because of which it will fly off, right? So to maintain the system in equilibrium, we need to keep a weight on top of the cope. So what is the weight of that? Simply we just subtract both of them for equilibrium, summation Fy equal to 0, and we get the weight which is coming out roughly around 2676.212 Newtons. So this is the final answer that is required.